Hey, my name is Ann. Thank you so much for joining me today where I'll be showing you how to multiply matrices. So let's get straight into it. There are two key things that we need to know before we can actually start multiplying matrices. And as you can see on the screen here, the very first thing is being able to identify the dimensions of a matrix. Dimensions, order, and size of a matrix, they all mean the same thing, and those terms are interchangeable. So the dimensions of a matrix is simply the number of horizontal rows followed by the number of vertical columns. In my dummy matrix on the screen here, I have 2 rows and 3 columns, which means that the dimensions of this matrix are 2 by 3. So this question is asking us to state the dimensions of the following matrices. Notice that when we name matrices, we actually use capital letters. When we use a lowercase letter that corresponds to the name of the matrix, we start referring to the individual elements within that matrix. Anyway, matrix A here has 1 row and 3 columns. So it is simply a 1 by 3 matrix. Matrix B here, now you can't go wrong with this one. It's a 2 by 2 matrix. Now matrix C here, you've probably already figured it out because we have 1, 2, 3 rows and 1, 2 columns. This matrix is a 3 by 2 matrix. Another way that you might see the names and dimensions of a matrix written in shorthand is the capital letter used to name the matrix, so matrix A for example, and then 2 subscript digits, 1 and 3 in this case. The first one shows the number of rows, second is number of columns. Matrix B here is a 2 by 2 matrix, and matrix C is a 3 by 2. The second thing that we need to know before we actually start multiplying these matrices is whether or not we can even multiply them. And that all has to do with this rule here. So 2 matrices can only be multiplied if the number of columns in the first matrix equals the number of rows in the second matrix. So matrix A here is a 1 by 2 matrix, matrix B is a 2 by 2, and matrix C is a 3 by 1. Let's start with matrix A. I know that I can multiply this by matrix B because the number of columns in the first matrix has to equal the number of rows in the second matrix. So I always like to write this down and just look for these 2 inside values. They need to be the same. If they are the same, we can go ahead and multiply. If they are not the same, we cannot multiply. Another thing that you may find useful is that the outside values, so the number of rows in the first matrix and number of columns in the second matrix, those 2 values give us the dimensions of our final product after we actually multiply the matrices. So if I multiply matrix A by B, I'm going to end up with a 1 by 2 matrix. Let's consider multiplying matrix B by matrix A. Number of columns in the first matrix is 2. Number of rows in the second matrix is 1. Because those values are not the same, we can't even multiply them. So that actually tells you that matrix multiplication is not commutative, meaning the order of multiplication can't be switched around for the same result. And in this specific case, A times B is possible, but B times A isn't the same because first of all, it's not even possible. Let's look at one more combination of matrices. Starting with maybe matrix C. Now we can post multiply matrix C by any matrix that has 1 row and however many columns. And in this case, it looks like we can actually multiply matrix C by matrix A because it has one row and two columns. These inside values are the same, so we can multiply. Okay, let's move on to actually multiplying these matrices together now. When you approach any matrix arithmetic question, if you haven't already, before you start any calculations, just do yourself a favor and write down the dimensions of each matrix. So this question is asking us to determine product AB, which we know we can do because the number of columns in the first matrix is equal to the number of rows in the second matrix. So the way that I like to set up my matrix multiplication just helps to keep track of exactly which row and which column we're using throughout this process. And honestly, that's the most confusing part about this. So if you can nail the setup, that leaves really little room for error. So we're going to start by writing matrix A down, 5, -2. And I'm doing that in a way that gives me enough space to write matrix B in this top right corner. And so I'm starting to create this backwards L shape and the perfect space for my answer there. Now, notice that my answer is going to be a 1/2 matrix, which is information that we can gather from these outside values here. So let's start by finding this element first. Now, we just need to see which row and which column lines up to our element. In this particular case, it's going to be this row and this column that matches up to my first element. Another way of looking at this is this element is in row 1 and column 1, and so I'm going to use row 1 from the first matrix and column 1 from the second matrix to multiply. So starting from the outermost values, the 5 and the 4, I'm going to multiply them, and then we're going to step in towards our element, so down and across to 3 and -2, and I'm going to multiply those together, and I'm going to add those two values. So 5 times 4 plus -2 times 3, or 20 plus -6, that's the same as 20, take 6, which is 14, and that's the value that goes there. Now we need to use the row and column that matches up with this element. And in this case, it's going to be this row, but not the first column. It's going to be this second column. So this row and this column matches up to this element, and those are the numbers that we're going to use. Starting with the outermost values, 5 times 0, and then stepping it in, so -2 times -1, and then we're going to add that together. So 5 times 0 is 0, plus -2 times -1, that's 2. 0 plus 2 is simply 2. So this question is asking us to determine the product BA. So B is being post-multiplied by A, or A is being pre-multiplied by matrix B. And in this particular case, matrix B and matrix A cannot be multiplied because these inside values are not the same. The number of columns in the first matrix does not equal the number of rows in the second matrix. So product BA cannot be determined. We do need to write a sentence though to state this. So we can say BA cannot be determined because the number of columns in matrix B does not equal the number of rows in matrix A. So this question is asking us to determine the product AI, which has nothing to do with ChatGPT, but has a lot to do with the identity matrix. So let's write that down first of all. I is the identity matrix. Now, when I'm referring to the identity matrix, that is a square matrix where the elements in the leading diagonal from the top left to the bottom right are all 1 and every other element is 0. The size of the identity matrix is kind of malleable. It kind of changes depending on what you need to be able to multiply. So in this case here, because A is a 1 by 2 matrix, if it's being post multiplied by matrix I needs to have 2 rows and therefore 2 columns because it's a square matrix. Because identity matrices are always square, we normally just refer to it with just one subscript. So I2 means that it's an identity matrix that has dimensions 2 by 2. So AI means matrix A, 5, -2, is getting multiplied by matrix I. It's a 2 by 2 identity matrix in this case, where elements in the leading diagonal are 1 and other elements are 0. Okay, now the identity matrix kind of acts like a 1 in matrix multiplication. If you multiply any matrix by the corresponding identity matrix, you know, the size that matches up, you're gonna end up with the original matrix still. This first element, I'm gonna be using this row and this column. So 5 times 1 is 5, -2 times 0 is 0. Add that together and we end up with 5. Moving on to the next element, 5 times 0 is 0. And then stepping in towards my element, -2 times 1, add those two values together, 0 plus -2, 0. Take 2, that is -2 in here. Moving on to our last example. Now, this question is asking us to determine the product CAB. So we are multiplying 3 matrices together now. The thing about matrix multiplication is it's not commutative, but it is associative, meaning that to find the product CAB, it doesn't matter what I group together first. So I can find C times A. Once I have that matrix, I can then post multiply it by B and I'll get the product CAB. Or the other alternative is you can multiply A and B together first of all, and then pre-multiply that by matrix C, and you'll end up with the same result. Okay, so let's start by writing down our shorthand notations. So C is 3 by 1, A is 1 by 2, B is 2 by 2. And I'm going to check if I can actually multiply these matrices or not. So again, I'm looking for those inside values to be the same. So between C and A, 1 and 1. And then between matrix A and B, I've got 2 and 2 there. So I'm good to go. My final product is going to be 3 by 2. They're the outermost values that give us the dimensions. Okay, so product CAB can be found. So I'm going to start by writing down matrix C. That's a column matrix because it only has one column. And then matrix A, which is a row matrix because it only has one row, in that top right space there, giving me this space here for my answer. And you can see that my product is going to be a 3 by 2 matrix. So for this first element here, I'm going to be using this row and this column. And in this case, there's only one element in each row and column. So all I need to do for this element here is to multiply 1 and 5 together. So 1 times 5 is 5. Now the next element, I'm going to be using this row, this column. 1 times -2 is -2, and that's what I'm going to write down there. This element here, I'm going to multiply 2 and 5, so that's 10. And lucky last, this element here, I'm going to multiply 2 and -2, which is -4. Okay, so now we have the matrix CA grouped together, and it's being post multiplied by B, so that's going to go up here. And my answer, which I might do in a different color bracket, is gonna be a 3x2 matrix. For this element, I've got 5 times 4 plus -2 times 3. So 20 plus -6, or 20 takes 6, which is 14. Moving on to this element here, I'm going to be using this row and this column, starting with the outermost values. 10 times 4 is 40. -4 times 3 is -12. So I've got 40 plus -12, which is 40, take 12, that is 28. And then very last element, I've got this row and this column that lines up to this element, starting with the outermost values. 10 times 0 is 0. -4 times -1 is +4. 0 plus 4 is 4. And there we go. We have our final answer. CAB is that matrix there in blue. Anyway, thank you so much for joining me today. I hope I showed you a nice range of examples that help you answer all the matrix multiplication questions. All right, bye.